So we've looked at evaluating unit circle for sine, cosine, and tangent. Now we're going to take a look at the inverse trig functions. So first of all, a reminder of what an inverse is. It's a function that undoes another function. So obvious examples, when you multiply by 7 and then divide by 7, you get back what you started with. When you take the sine and then the sine inverse, you get back what you started with. So the inverse functions input a ratio, like square root of 3 over 2, 1/2, square root of 2 over 2, and they output an angle in either degrees or radians. And today we're going to be focusing on degrees. So because the unit circle cycles forever, the trig functions are not, they do not pass the horizontal line test, which tells us whether or not the inverse is a function. So when we're looking at the domain restrictions, we have to limit the domain of the sine, cosine, and tangent in order to have a piece of the graph, which we haven't seen yet, be the limited domain. So we're going to start with sine inverse. So the domain for sine inverse is -1 to 1 because the output of the sine function is between -1 to 1. The range of the sine function becomes the domain of the inverse. And we restrict the domain of the sine function to -90 degrees to +90 degrees. So when we think about our unit circle, and we think about those values that we get in the unit circle, remember the sine? So we've got cosine theta is our x-coordinate, and sine theta is our y-coordinate. So the sine value is positive in the first quadrant and negative in the fourth quadrant. So because that is a continuous piece of the unit circle, this is what we use for our restricted domain, -90 degrees to +90 degrees. And if you notice, that's the same restricted domain for the tangent inverse for the same reason. The tangent is positive in the first quadrant and negative in the fourth quadrant. While I'm talking about tangent, let's jump to that one. The domain for the tangent is all real numbers. That's what this first R is for, all real numbers. Because the output of the tangent is all real numbers. And then finally the cosine, when we look at the cosine and this restricted domain that we used for both sine and tangent, cosine is your x-coordinate, so it's positive in the first and fourth quadrant. So that would give us some repeat values. So what we do for the cosine function is we go from 0 degrees, where cosine's positive, and then over into the second quadrant, where cosine is negative. So that is a restricted domain for the cosine inverse function, or the range that we look at. So let's take a look at some examples. Our objectives today to be able to evaluate inverse trig functions in degrees, and we're going to start to look at solving some trig equations. So first of all, we're going to evaluate the inverse functions, and as I mentioned, we're only going to be giving our answer in degrees today. So for this one, if you think about where on the unit circle does the sine equal the square root of 2 over 2, and we only look at the restricted domain for the sine function is -90 to +90. Well, since our input is positive, we know we're in the first quadrant, and we have memorized that 45 degrees is where the sine value is square root of 2 over 2. Tangent inverse has the same restricted domain, the -90 to +90 degrees, so we're looking at the same region. We notice that we're taking the tangent inverse of a negative, so we know we're in the fourth quadrant, so we know our answer will be negative because we're rotating. Remember, the negative means we're rotating clockwise, and positive we're rotating counterclockwise. So we know that our degree is negative, and the negative square root of 3 over 3 we have memorized is 30 degrees. And finally, cosine inverse of 1. So cosine inverse is the one that has a different restricted domain. Let's see if I can slip it down. So I am going to sketch a different picture of the unit circle. So we're going from 0 to 180 degrees for the cosine inverse. And we're thinking about where is our x-coordinate equal to 1? Well, over here, we have the point 1, 0. So the cosine inverse of 1 is 0 degrees. All right, so now we're going to take a look at solving some trig equations, and we're going to be giving exact general solutions, and I'll explain what that means for each trig equation. So a general solution means every single possible value of theta that when we take the tangent of it would give us the square root of 3. Well, there are an infinite number of angles because you can keep rotating around the unit circle. So what we do is we look at what's called the period of the function. So let's talk about the period of the tangent function. And what I want you to think about is, remember, for the unit circle, tangent starts positive in the first quadrant, negative in the second quadrant, positive in the third, and negative in the fourth. So it has this pattern where it repeats every 90 degrees, we're in degrees. So every 180 degrees. So we start at 0 degrees, and then when we rotate to 180 degrees, we start back over and we're getting those exact same tangent values from 180 back up to 360 degrees. So the period of the tangent function in degrees is 180 degrees. So every time you add 180 degrees, you will get the exact same tangent value. So we're going to use that when we find our general solution. So the first thing I'm going to do is cancel that tangent by taking the tangent inverse of both sides. And it's positive. The restricted domain for the tangent inverse is from negative 90 to positive 90, so I know my answer will be in positive degrees. And I've memorized that the tangent of 60 degrees gives me the square root of 3. So that is our restricted domain solution. And then we add the period to it. So theta equals 60 degrees plus 180 n, because as I mentioned, every time you add 180 degrees, you're going to get that same tangent value back. All right, so for cosine, the second example, the first thing we need to do is obviously get the cosine by itself. So I'm going to divide both sides by 6. And simplify that to negative 1/2. And then I'm going to think about the restricted domain of the cosine function is from 0 to 180 degrees. So I'm going to think about where on the unit circle between 0 and 180 is the cosine of theta equal to negative 1/2. And that would be at 60 degrees, 120 degrees. So I memorized that the cosine of 60 degrees is positive 1/2. So when I reflect that over into the second quadrant, I'm getting 120 degrees. And then there's actually another piece to this. So when you see it next year in pre-calc, hopefully you don't think that I didn't know about this. I'm just going to skip it because we're doing an introduction. So we're just going to do the one solution for now, but there is another solution to this. The period for cosine and sine, because they don't repeat in the same pattern that tangent does. So let's think about unit circle. Remember, cosine is positive because it's our x-coordinate, negative, negative, positive. So it doesn't repeat until you make one full cycle. So it's a full 360 degrees. So we'll only get back to that same value when we're adding 360 degrees. But as you can see, so here we are at 120. There is another value down here where you get the same cosine, where the cosine is negative 1/2 as well. That's the piece that we're skipping right now. And finally, sine. So the first thing I'm going to do is divide both sides by negative 2. And then take the sine inverse of both sides. So thinking about that restricted domain, let me just use this one again. The restricted domain for the sine is from negative 90 to positive 90. Since I'm taking the inverse of a negative, I know my answer will be negative because it will be an angle in the fourth quadrant. And I have memorized that the sine of 60 degrees is square root of 3 over 2, so I get negative 60 degrees. And using the same unit circle, sine value is our y-coordinate, So we are positive in the first quadrant, positive in the second quadrant, negative and negative. So again, the period for the sine function is that full rotation, because it doesn't have that nice pattern that tangent does. So 360 degrees times n.